Hey friends, in today's lecture, we are going to do hands-on of linear regression with TensorFlow. So first of all, our objective is to learn to implement a simple linear regression model to predict continuous values. Let's recap the theory of linear regression. Linear regression is a model that assumes a linear relationship between input variable x and the target variable y. Input variable x is also known as independent variable, and target variable y is known as dependent variable. So what is the equation of linear regression? Linear regression equation is like a simple line equation, that is y equal to mx plus b, where m is the slope, that is also known as weight, and b is the intercept, that is also known as bias. What is the goals of our today? Our goal is to minimize the difference between the predicted value y cap and the actual value y by adjusting the parameter m and b. Okay, so let's start our hands on. I will also describe line by line code so that you can get full understanding of the TensorFlow. Define the input data. Okay, so here first of all I need to import TensorFlow as TF. After that I will create input data and I will create the label corresponding to that data. Okay, so capital X is our input feature, our input data. So capital X is equal to TF dot constant. Using TF dot constant I have created a tensor, and the value 1.0, 2.0, 3.0 and 4.0 are the value. Using these value I will create my input data or input feature. Okay, and here is my data type. After that I will create my output data, that is also known as label. So here capital Y is label, and using tf dot constant I have created the tensor, and here is also 4 element in my tensor. Okay, now I will run this code. You will see what is the output. Okay, so my code has been successfully run. Now the second task is to define the variable. Okay, so in my equation y equal to mx plus c, m and b are the variable which I need to define. Okay, so using this code, m equal to tf dot variable and b equal to tf dot variable, I have assigned the variable. I have defined the variable. Now I have to define the linear model. My linear model is mx plus b. Okay, so using a function linear underscore model, I will define my linear model and I will run this code. Here my linear model is also defined. Now I will define the loss function, that is mean square error. So remember my friends, when you use regression and you want to calculate the loss, then in regression we will use mean square error, mean absolute error or Huber loss as loss function. But in case of classification we will use binary cross entropy loss as a loss function. Okay, so here we have to calculate mean square error as a loss function. So I have created a loss function here and I have passed the value y true and y spread. Y true is the actual value of our output, and predicted is the predicted value of our output. Okay, so our loss is the difference between true value and the predicted value. So here is the formula of loss is written: return tf dot reduce mean, this is mean square error, and we have taken the square difference, average of square difference of true value minus the predicted value. Okay, so here it is represented by python coding: tf dot square y true minus y pred. I will run this code. I will run this code, and now my loss function is calculated. Okay, now I will implement the gradient descent for optimization. Okay, once you calculate the loss and you have calculated the difference between actual value and predicted value. Okay, after calculating the loss you saw that there is a difference, there is error between both value and actual value. Then at that time you will use optimizer to minimize the loss. So here optimizer SGD is used. SGD means stochastic gradient descent optimizer is used to optimize our loss function. Okay, so optimizer equal to tf dot optimizer SGD then learning rate equal to 0.01. Learning rate should be not too high or too low, it should be in average. So 0.01 is best value for the learning rate. Okay, so this program is also run. Now we have to run the training loop, and here I will tell you what is the line by line, code by code explanation about this code. Okay, so that you can get a full idea about the code, and you can get a full idea of the TensorFlow. So you can see here a code written as for epoch in range 1000. What is this? This line initiates a loop that run for 1000 iterations. In the context of training a machine learning model, each iteration is called an epoch. The loop will run 1000 times, corresponding to training the model for 1000 epochs. So this is meaning of this single line of code. After that, you will see a code with tf.gradient tape as tape. So what is this gradient tape? So in TensorFlow uses a gradient tape to record operations for automatic differentiation. Okay, so gradient tape is used to record operations for automatic differentiation, which is useful for calculating gradients. The block inside this with statement record the operation on the model parameter like weight and biases. And you can see in next line of code y underscore pred equal to linear model, and after that we have provided the input value, that is x. So this line calls the linear model function which generate the gradient y predicted based on the input data x. The linear model represent the relationship between input feature and output level, that is target y, using parameters such as weight and bias. Then next line of code you will see loss equal to loss underscore function y comma y pred. Here the loss function compute the loss between the actual target value y and the model prediction y pred. The loss function quantify how far the predicted value are from the actual value. So in supervised learning we use the label data. So we have already an information about the input and output of the data. Common loss function include mean square error for regression and cross interval loss for the classification. That's I have told you that for classification we use cross entropy loss as a loss function, and for regression we used mean square error and mean absolute error and Huber loss as a loss function. Now you will see the next line of code, gradient equal to tape dot gradients, and in bracket we have provided the parameter loss and our variable, that is m and b. Now next line of code you will see optimizer dot apply gradients, and after that we have zip the gradients and the parameter. Here the optimizer update the model's parameter weight and bias based on the gradient. The apply underscore gradient method adjusts the parameters using the gradient descent algorithm, which try to minimize the loss by updating the parameter in the direction of steepest descent. And the zip gradients, this pairs each gradient with its corresponding parameter m for weights and v for bias. This condition checks if the current epoch is a multiple of 100 or not. It ensures that every 100 epochs some information or loss is printed. Print epoch, and after that curly bracket epoch and loss. After that loss dot numpy. What this line of code do to us? If the above condition is true, if this condition is true, that is every 100 epochs, this line print the current epoch number and loss value. So the dot numpy method converts the loss from a TensorFlow tensor to a standard numpy array or a scalar, easier printing. Okay. So as a summary, this model makes prediction y pred using the input data, and the loss is calculated between the predicted value and the actual target value. Gradient of the loss are computed with respect to the model's parameter, and the optimizer updates the model parameter using these gradient to minimize the loss. And every epoch the current loss is printed to monitor the training process. So I hope this explanation clear your doubts about the code. Now I will run this code and we will see what is the output. Okay, so when I run this code, you can see here is epoch and here is loss. So as our epoch is increasing, our loss is decreasing. So you will see in our first epoch the loss percentage is 16.87 point, that is too much high. And in our first epoch, that is epoch 100, it's 0.0191. It's reduced exponentially. And after that, in next epoch, it's lesser than the previous epochs. Okay, and as our epoch is keep on increasing, our loss is keep on decreasing. Okay, so this is our training data. Okay, this is our training output. Now we will evaluate the final parameter. So let's see what is the final parameter. So my final parameter, our trend weight that is 1.99, that is around to 2, and our trend bias is 0.02. Okay, so in our linear equation we will put the value of y, we will put the value of m and b and predict the value of a new data. So in equation y equal to mx plus b, we will put the x, m and b and we will predict the value of y. Okay. So the model should adjust what is the expected output. The model should adjust the weight m approximately 2 and the bias approximately 0 after several iterations. You will observe the loss decreasing over time and model learn. Okay, we have seen that loss is decreasing over the times as the epoch is keep on increasing. So this is a small hands-on for linear regression with TensorFlow to clear your concept. See you soon in the next hands-on session with some other idea. Till then, keep exploring and keep learning machine learning and deep learning.